Hello everyone. Yes. So how's everybody? Hello Aman. Hello Suryank. Hi Brijesh. Yes, am I visible and audible to everybody? Yes. So guys, today we are going to start with this properties of solids. Last time we discussed about the gravitation. So this time we are going to take up this topic. Okay. And I'll just give a brief introduction to this chapter. Then we'll just take a few questions, right? So yes. So yes, let me just start off the session, guys. Okay. So yes, the properties of the solid, where I'm going to start with the Hooke's law. Okay. Yes, a great evening from my side, guys. All of you who have joined the class. Okay. So this is the Hooke's law, guys, where the stress and strain are directly proportional to each other. Means they are connected with the linear graph. And if I just talk about the slope here, so slope of this stress and strain curve tells me the modulus of elasticity. Okay, the tan theta, or you can say the slope, just tells us the modulus of the elasticity. Like if you're just considering about this one, a length of the wire which has initial length as L naught, and if you're giving some force to it, so definitely it will just elongate a bit. Okay, so we just call this elongation here is delta L. So here you can see, if I just talk about this curve, that stress is directly proportional to strain. And once you remove the proportionality sign, so what I'm going to introduce, I'm introducing a constant here, that is I'm introducing as M, and this is the strain. And here, this stress upon strain gives me this one, and this is the modulus of elasticity. And here, this is nothing but the slope of the curve. Okay, so here if I talk about this one, what is happening here, so we define for the longitudinal strain and the longitudinal stress, we define the Young's modulus, that is the ratio of stress upon strain. And here it is longitudinal stress upon longitudinal strain, right? So if I talk about here, so this is force upon area, and this is delta L upon L. So this is the expression that we are going to use in the numericals. Okay, everybody? Yes. So similarly, we do have the bulk modulus. We do have the bulk modulus, okay, where it is defined as P. And again, here, suppose I do have a bubble from the external, some pressure is being acted on, okay? And you know that when the pressure is being acted on the bubble, what is happening? Its size will get decreased, isn't it? So initial volume I'm considering as V, and the change in the volume I'm considering as delta V, right? So I can write it here as F upon A delta V and V, okay? Or F upon A, you can represent it as pressure here, that is delta V upon V. Okay, so these are the few modulus, and one more modulus I need to discuss it here. Just a moment, guys. Yeah, one more modulus I just need to discuss here, that is modulus of rigidity. Okay, modulus of rigidity, that I'm going to represent as eta. Okay, so what is happening here? Suppose I do have a cube, and where I'm just applying some tangential force to it. Okay, excuse me. So what is happening? It will just get displaced by a small angle as theta here. So this theta is nothing but the tangential strain. Okay, so what I'm going to represent here again, this is eta, modulus of rigidity is what? F upon A, and this is theta. Theta is what? Length of arc upon radius. So what you can write it here, this side, suppose it just moved for small amount delta x, and this length is L, so I can write it here as delta x and L. Okay, this is the modulus of rigidity. Okay, so yes, these are the modulus, and m- uh, mostly you will find at least one or two problems from this side. So let me just take few numericals on this. Okay, so yeah, before just starting of the numerical, I just need to tell you one more thing. We can just discuss it here about the thermal stress. Suppose I do have a wire here, okay, and its length is L. Whenever I'm giving to heat, whenever I'm giving some heat to it, what is happening? It will try to expand, right? And the expansion formula, you know that this is L equals to L naught 1 plus alpha delta T. Delta T is the change in the temperature. Alpha is the coefficient of linear expansion. Okay. So if I wanted to write delta L here, so delta L is nothing but L naught alpha delta T, right? So if I wanted to write in the same term that I have discussed just few minutes back, so Y is equals to, that is thermal stress, I'm going to put it as F upon A, and this is delta L. Delta L, I can write it in this form, L naught alpha delta T, and here L, right? Or you can say initial length is L naught, so this will get cancelled out. So you can write it in this way, that F upon A alpha delta T, right? So these things also come in the exam. Okay. Yes, so yeah, let me just take up a question here. So coefficient of the linear expansion for the brass and the steel rods are alpha 1 and alpha 2. Okay, length of the brass and the steel rods are given as L1 and L2 respectively. If L2 minus L1 is maintained same at all the temperatures, means the change in the length will be same for all the temperatures. So which one of the following relations holds good here? So yes, for it's the 11th class chapter actually. Okay. Yes. So yeah. So here you can see here that the length, whenever I'm giving heat to it, its expansion, the difference in the length, or you can say the elongation here will be same. So I can write it this one. So how would you write this one? L1 alpha 1 delta T is equals to L2 alpha 2 delta T. And you just need to equate these two and you will get this one. That's all. Okay. So here, this is very simple question here. So this one is the correct one. Okay. So here, this is the answer for this question. Okay. So no need to derive so many things, but it's just based on the simple thing. You just need to put emphasis on the language, whatever it is written. You just need to try to understand what the problem is saying. Okay. So here I do have another question where copper of the fixed volume V is drawn into a length of the wire L. When this wire is subjected to a constant force, what I'm doing is I have a wire here which has a constant volume V, and what is happening? It has a length L. Okay, so I'm just applying some constant force to it, that is F, and the extension produced in the wire is delta L. So they have given the extension as well, and that is nothing but delta L here. Okay, which of the following graphs is a straight line? So a straight line will be happening when it has a graph like y equals to mx, right? Then we do have a straight line like in this way, right? So we need to just like figure it out which one is the correct one. Okay, so let's just write up the formula here that we have studied. So y is equals to f upon a delta L L, right? So here, if I just need to write if I need to write, I just need to draw the graph between delta and the rest of the quantities. So I can just put it in this way. Okay, sorry, I can put it in this way, right? So delta L is equals to, can I write here area as volume upon length, isn't it? So I can just put it here as volume upon length. So it will become L square, and this is Y. And you can see here that rest of all the quantities are the constant. So what you can do is you can figure it out that delta L is directly proportional to the L square, right? So if I'm just drawing a graph between the axis of delta L and L square, so it would be a straight line, right? So we do have the answer here, delta L and L square. Just a moment, this one. Okay, guys, okay, is that fine? Okay, so let's move to the next question here. You guys can ask me doubt if you guys have any. Okay, so the following four wires are made up of the same material. Which of these will have the largest extension when the same tension is being applied? So this is another, like, this question has been asked in a lot of exams. I guess this question has been asked in IIT as well. Okay, so you know that this is the Young's modulus, that is F upon A delta L L, right? So the wire diameter is given. So area, you can write it as, just a moment. Here you just need to figure it out which one have the largest extension. So if I just put it in this way, delta L is equals to F, L, A, and Y. So just forget about these F and Y because these are the constant everywhere. So delta L is nothing but proportional to L upon A, right? And A, you know that proportional to D square, because you need to just put it as pi r square, right? And L, you just need to put it in this way only. So what you have to do is you have to just figure it out. Delta L for the first case, if you just do it length upon diameter square, what would you get? You just need to put it in the right dimensions, means right units. Okay, so you can put it as 0.5 upon d square. What is d square here? Diameter is coming out to be 0.5 whole square. Okay, second one, again this is for the L1, delta L1, this is for delta L2. So again it is coming out as 1 upon 1 millimeter, right? So again I'm just putting in this way. Guys, just give me a moment, okay? Excuse me. Yes, so yeah, so now just a moment. Yeah, so now you can see length for the C option is proportional to 2 upon 2 square, right? Somewhere 2 upon 2 square. And you can see for delta 4, okay, let me just put it here only. So delta 4, L4 is proportional to 3 upon 3 square, right? Right. So what is happening, guys? Which one quantity is getting big? So if you're solving it, this is almost coming to 1, almost coming to 1 by 2, almost coming to, what is this, 1 by 2, and yeah, I mean it was coming out as 2 only. And here it is coming out to be, how much is that? 1 by 2, right? Yeah, okay. So here it is coming out to be 3 diameter, right? So 3, 1 by 3. Right, so what you can see here, the extension produced the same extension. Which one is greater, guys, out of all them? Out of all them, which one is the greater? Can you just predict it from here? Guys, I'm just waiting for your response here. I'm not seeing any responses. Yes, yes. So you can see here, everywhere it is, when you are putting length divide by the area, and you are just doing the square of the diameter. So here, if you are seeing the ratio here, so this is length upon this area, length upon this area, and you can see here, this is the largest extension that is being coming. Okay, so according to that, you can just pick up the right option. That's all. Okay, any doubts, guys? Because here what I have done is, I would have taken radius as well, but again it is proportional to diameter, so no need to just put it in the form of the radius. Okay, fine. So I guess when we have another question, last question, I guess, right? So this one, the bulk modulus of the spherical object is B. If it is subjected to uniform pressure P, the fractional decrease in the radius. Okay, the fractional decrease in the radius, what is happening here? What is a fractional decrease in the radius? That is delta r upon r. This is the fractional decrease, because what is happening when the pressure is being applied from the outside? What is happening? The radius will definitely decrease, because I just told you that when we just put it bulk modulus in the formula, that is pressure upon delta V upon V, right? So here again, this delta V is nothing but the minus, means it's the change in the volume, right? So this is, I'm going to put it here, that V is equals to 4 upon 3 pi r cube. Just a moment. V is equals to 4 upon 3 pi r cube. Okay, so here uh, what you have to figure it out, the bulk modulus is given here, this one. If it is subjected to a uniform pressure, you have to just figure out the fractional radius change. Okay, so you just derivate it on both the sides, so this will become dv, and with respect to radius, so this will become 4 upon 3 pi 3 r square, right? And this is, that's all. And what you do here, you just put it, dv is equals to 4 upon 3 pi 3 r square dr. Okay, and what you do is, you just divide it with this equation, the original equation. So what would you get? V, and this is 4 upon 3 pi r cube. This will get cancelled out here, only r will be remaining. So here dv upon v is coming out to be 3 dr upon r, right? So this is a bulk modulus, that is pressure upon delta v. So you can put it in this way, delta v upon v, okay, is equals to p upon b. And what is delta v upon v? I mean, you can just put it in delta v upon v as well, right? So similarly, it will become 3 delta r upon r, right? So this is 3 delta r upon r is equals to p upon b. And here, what you can see, that delta r upon r is coming out to be p upon 3b. Okay, so this is the fractional change in the radius. So here you can pick up the right option according to the options given. This one is the right one. So guys, these are the questions that we have taken, means according to the Young's modulus and the bulk modulus. Okay, these are the few questions. So that's all guys from my side. Okay, so rest of the updates you can see it on the website and these links. Thank you so much guys for attending up the session, and we will be meeting up in the next session with a new topic. Thank you so much guys. Bye bye, take care.